Okay, let's look at the g function is equal to 2 plus 4 log x. Okay, now let's just look at log x alone. Okay, because these are all constant. Now let y equal to log x. Now equal. Now we can rewrite this equal to e y x. Okay, now if you vary the value of y, you notice that x can never become negative. Okay, whatever value you change, the x cannot be negative. That means x is given as bigger than 0. Okay, this one we know very well. E to the power of y, no matter what value of y you put, x cannot be 0. Therefore, is given here. Even in the question, x has to be more than 0. Okay, in other words, x equals to 0 or the y-axis is the asymptote. That means the graph will be very close to the y-axis, or x equal to 0. The line x equal to 0 will be very close, but it will never reach the line, the y-axis. Okay. Now, if you look carefully, okay. Now, I mean, when the x is very close to 0, the curve will be either go up this way or go down this way. Okay, but very close. What I mean is either this way or it's either this way. Okay. Now, let's look at that. That's the first point. Okay. I mean, at this point, very close, or it can be this direction. Now, let's look at analysis on this. When y equal to 0, y equal to 0, e equal to 0, so this 1. Okay, in other words, the x-intercept, which means when y equal to 0, okay, for this function is 1. That means when y equals 0, it passes through the point 1. Okay. Now, so that's the second point, how you sketch a graph. Now, let's look at when x is when y is increasing, that means it's going this direction. Okay, what happened? This is the third point. When y increase, x also increase. Okay, but which one will increase more? When y increase, because x is the is equal to the exponential of e for y. So a slight increase of y will make a big increase in x. So if that's the case, it should be this manner. Okay, a slight increase in x, it will give you a great increase in a slight increase in y will give you a big increase in x. Okay, a small increase here, you can see the x is increased more in this case. So this part of the curve is in this direction. Okay. Now, So we have determined this part of the curve. Now what about when x is less than 1? I mean 0.5. Let's look at it. Let's say x is 0. When y is minus 0.5. What happened? So this is 1 over e 0.5. Okay. This value will give you a value that is less than 1. I mean when x is equal to minus 5, this part here, and you get a x value which is less than 1, so it's here. So obviously if you look at this couple of points, so you will expect this one has approached x intercept, so it cannot reach, but you run very close to it, and then look at this curve, look at this function. When y increase slightly, because the exponential x will increase a lot, so it's curving this way. So this is y equal to log x. Okay. Now if you put a 4, y equal to 4 log x, wherever the same value of x, the y value is increased by 4. So basically it's referring to a case where you have a steeper one. Okay, a steeper curve here, and also you have a steeper curve here. Okay, now let's change another color. No, less green. Okay, now let's put 2 inside. What happened? Actually means the whole graph is shifted up. Okay, so this is the final graph which represent y equal to 2 plus 4 log x. Okay. Now you also notice that before I put in the constant 2, the x-intercept is at y equal to 0, x equal to 1. Okay. So if you shift this whole thing up, then the x-intercept for this is not when x equal to 1, is somewhere in between 1 to 0, the x value. So you're aware of this now. Okay, so let's look at the function gx. We got 2 plus 4 log x as given the domain is more than 0, x more than 0, and then the range, which is the value of the function, this is the value of the g function. You can see that here the y can be continued, or y which is actually equal to g function. Okay, the y value can be continued to increase, or the gx function. Similarly, the y value can be decreasing until minus infinity. Okay, I mean the gx function is a whatever value of gx function is the elements of